It's fantastic to be joining you again from the Cisco booth live at Mobile World Congress, Barcelona. Today, I'm going to be speaking to several experts to understand how Cisco is shaping a new era of intelligent network fabric. In particular, I want to explore the major shifts for this transformation and how AI represents the evolution of connected systems rather than being a single breakthrough. And also how the network is going to shift from a supporting role into a critical platform. So I'm going to start now by talking with Kevin, and we're going to be talking about the network fundamentals. So thanks for joining me.
Hey, thanks for having me again. I love this.
I love it. We're here again this year on the Cisco stand. So traditionally networks have been seen purely as kind of delivery mechanisms. Perhaps you can start by telling me how this is going to evolve with AI and how the changes to network infrastructure, what this means.
Yeah, and I mean, AI's been around for a long time, but it's only been the last 2 or 3 years where we've really seen massive build-outs because of AI. And most of that has been large training networks and the hyperscalers really building infrastructure. But what we're really excited for is as more and more users start to actually leverage AI in their daily workloads, I think you're going to see a transformation of how the data centers are built and how networks are built. So think about customers that want to do inference and basically take these large models and actually run their own AI workloads. They're going to have to think about not only capacity of the network and the speeds and feeds, but how the networks are actually built. And so we think we're going to see a large transformation in not just our service provider networks, but our enterprise networks, mobility networks, to really handle the increased workloads from AI.
And I guess also from an operational perspective, it's obviously, operators are really concerned about security. So how do you build in this, heightened security while keeping the simplicity for operational management?
Yeah, well, think about it this way. We're moving from this world of chatbots and simple interfaces to AI to these agentic workflows. And so people are going to have 1, 10, hundreds of agents actually working on their behalf. And so if you think about the way traditional network security works, you would get someone's identity, go out to a centralized firewall, decide whether or not that person would have access to something, and then either allow them or disallow them. Now you might have thousands of agents or hundreds of thousands of agents. And so even the way we used to do identity and policy and security aren't going to work in this future world. And so as we think about evolving networks for capacity reasons, we also have to think about completely transforming how we identify agents, how we tell if agents are misbehaving, and really how they're going to work in this new AI world. And this is just the beginning. Today we're seeing huge increase in numbers of agents. We just had some really fun stuff over the last few weeks of agents communicating with each other and doing some really bad things on networks. But as you look forward, we're going to move outside the walls of the data center. So think about things like physical AI. When you walk around the floor here, you'll see a bunch of robots and other things. And there we've got to think about securing remote devices that are running out in the physical world. And so physical security, network security, agentic security, all these things are going to have to be fused in and integrated in the network. And that's some of the stuff we're working on here.
Yeah, fantastic. I mean, that is a completely different evolution from traditional networks. Well, thank you. I'm now going to move over and talk to Bill. So thanks very much for chatting with me today, Kevin.
Thanks a lot. I appreciate it.
Welcome back. I'm now speaking with Bill, and we're talking about optical and optics innovation, and specifically how recent innovation is really supporting AI. So perhaps we could start there.
Well, really, there's 2 key areas. One is what's happening in scale across applications in moving traffic between data centers. And in that application, we're leveraging coherent pluggable optics at 400 gig and 800 gig. And our customers include all of the hyperscalers and over 450 service provider customers who are now deploying this technology that gives them immediate CapEx and OpEx savings. It's a really significant innovation driven by Cisco. The second area are the optics that are inside the data center, used in AI infrastructure. And what we've learned is that the reliability needs for that optic are much more pressing than the reliability needs for a classical network. In an AI infrastructure, if a link has an error burst or a link flap, all of the GPUs that are operating in parallel need to stop, back up to a checkpoint, and restart. It's very inefficient. In a classical network, if an error burst occurs on one link, TCP/IP bridges that error, and no neighboring links are impacted. So it's a very different implication for an error burst in an AI network versus a classical network. And one of the things that we know, having looked at a lot of the optics in the industry, is that many optics suppliers claim compliance with all of the optical specs and all of the electrical specs. Yet when we've tested them, we've found that most of them do not satisfy the compliance requirements under all operating conditions like temperature, humidity, and different host environments. And what Cisco does is we qualify our optics not only against all the relevant specs, but under all operating conditions and all combinations. So we assure our customers that our optics are going to be the most reliable optic in the industry.
So you just mentioned bandwidth, power, and also efficiency. Obviously, that's really important to operators. How's the innovation supporting this when we see AI come along?
So one thing that's foundational for us is silicon photonics. Silicon photonics basically allows us to integrate the optics components into silicon, and we're leveraging conventional CMOS technologies to do that. The reason we do that is, number one, it allows us to leverage CMOS fabs that are highly reliable, so we get a very reliable solution in the end, but we can get power savings and cost savings by doing that. So our silicon photonics platform is used not only inside the data center in optics, but also in our coherent optics. That silicon photonics platform will evolve over time. So today we offer a full range of optics for the data center, everything from 1 gig to 1.6 T. But that silicon photonics platform will allow us to support new applications like LPO, or linear pluggable optics, and CPO, or co-packaged optics, where we're trying to reduce the power for our customers. And beyond that, we'll see continued innovation in areas like 1.6 T and beyond.
Yeah, well, there's a lot going on, really. So thank you very much for talking to me, Bill. I think I'm going to be chatting to Denise next about sustainability and efficiency.
Thank you for having me.
Thank you. So I'm now speaking with Denise. Great to have you here.
Great to be here.
So Denise, how are you supporting this fast and rapid growth of AI to enable you to build these data centers really, really fast, but also within the energy constraints?
Yeah, it's a question that is so important around the globe. You really can't go anywhere without understanding that our energy capacity is a hard ceiling for any data center growth. What we're seeing in cities and towns out to countries and regions is negotiating power between AI boom and even those of commercial and even residences. And when you think about where Cisco has played for a long time, energy management is something that has been inherently built in to our entire platform. So even 4 years ago, we started under the banner of sustainability and tracking. We need visibility of energy just the same way we need visibility of our networks. So energy management with OT in the data center, working with Splunk, which was a great partner and acquisition to make all of this data readily available. What you heard from Kevin and Bill is we are integrating energy efficiency into every product, every part of the architecture, because inherently the very simple way to think about it is if you build these things earlier on to be integrated, it's by definition more efficient. Right, and so that's what you're going to see with all of our new products is this inherent underlying energy management, so you have visibility, and then you see the integration of product, whether it's making things more simplified, making it more optimized in how we build it, introducing new technologies like direct-to-chip cooling, like we see in our new switches. There's just a lot coming, and I think just because we want to build fast doesn't mean we have to sacrifice efficiency.
So really, I think you've just spoken about, you've got to prioritize energy efficiency, but how are you also enabling these solutions to be both scalable, but also profitable as well?
I'm so glad you asked that question because there's a lot of folks who claim to have ideas and solutions, but the really big tricky part right now is speed and scale. And there's very few companies that customers trust around the world. When you're starting to talk about things like power and cooling, and you start to talk about energy in the rack and getting power to the rack at voltages that are actually quite dangerous. And so what we're doing, I would say, is I'll highlight two things. One, I'll talk about the innovation side. So on the power side, we have actually continued to innovate with new technology. One thing I'm very, very excited about, if you've seen me, you'll know that I carry these cables around with me everywhere I go. But 25 years ago, Cisco developed power over Ethernet technology, and we introduced power to the same cables that we have data, right? So think about safely, securely networking power the same way we do data. This is great, but this PoE cable has a limit of 100 watts. Those same engineers were asked what comes next. And what comes next is a new technology called fault managed power. Terrible, scary name. But FMP is a new technology, and each of these twisted pair today, commercially on the market, can do 1,000 watts.
Wow.
Right? And there's 8 twisted pair on this. So you're talking 100 in this, 1,000 in just one of these little ones, right? Now, we're partnering today with an ecosystem of partners to bring some of this technology to market. We're working on our own solutions. But what's exciting about this is the second part. So yes, we're innovating, but we're also building these ecosystems. And building these ecosystems and integrating with partners so that by the time these things come to market, customers can see a whole solution. And they can benefit from how things work together because they've already been designed together, they've been built together. And then last but not least, we're working with a lot of these standards bodies, industry groups. All this stuff is happening so quickly. If we don't work collectively and together, there's no way we're going to get to the speed and scale that the industry is requiring right now.
So that's fantastic. It's really good to hear how energy and efficiency, they really are and must be hand in hand as we move into this AI era.
Yeah, that's right.
So I've spoken to the experts, and I now understand what's going to be part of the intelligent fabric of the AI era. We can see that it needs new network foundations, accelerated intelligence, and innovation for both optics and optical networks, really to create the sustainable architecture for the future. Thanks very much.